Alright, now we're going to take a look at the frequency page for the oscillators. So here we have the frequency control for oscillator 1. If we look at this top left corner, we can see there's a keyboard icon, which means that this oscillator will follow keyboard tracking. If we press the octave control there, that keyboard icon goes away. And now the oscillator is no longer tracking the keyboard. Let's go ahead and turn tracking back on. Obviously, this encoder is controlling the octave range for this oscillator. Here we've got our pitch. We can adjust our pitch in semitones. And we see as we go lower than an octave, the octave control is also updating its value. If we would like to clear out the overall pitch, we just press that pitch control, and now we're defaulted back to octave 0, pitch C, and a fine tuning of 0. Here we've got our fine tune control. And there are, I believe, 128 steps per semitone, which actually gives you finer resolution than your typical 1/100th of a percent being a cent. If we'd like to clear out this fine tune, we can press the knob and it takes us to 0. Again, if we continue to rotate this past one of those boundaries, then the pitch and the octave update. Again, if we want to clear them all out, we just press the pitch control, and we're back to our starting point. This bottom parameter here that's called detune is actually constant beat detuning. And the best way for us to hear this is going to be to listen to two oscillators at one time. So I'm going to go to oscillator 2, set it up to be the same octave, go back here to oscillator 1, and I'm going to move our mix joystick to be an equal balance of oscillator 1 and 2. Now at this point, they are in perfect unison. You can hear a little bit. That's what we typically hear in an analog synthesizer when we detune them to make the oscillators sound fat against one another. The thing you'll notice is when you use just a fine tuning to detune the oscillators, that the beating between the oscillators changes as you play the low range versus the high range. Let's check that out. So this is a much slower beating between those frequencies compared to the high notes, which are much higher frequency. Fast, slower, slowest. In some cases, you want that beat detuning to stay constant, and that's what this is for. Let's dial this up. Now as we play higher, lower, that wash of detuning, kind of like an LFO effect, stays at the same frequency no matter which note we're playing. I'm going to turn up our glide a little bit here. Now, in addition to that constant beat detuning effect, we can actually use this to shrink and stretch the keyboard tuning slightly, and then offset that with our fine tuning to match up with the other oscillators. So this ranges from +5 all the way down to a -5 Hertz. So when we dial it for 5 Hertz, that's the beating frequency that we're going to hear. As we slow this down, so 1 Hertz means it should take 1 second for that washing sound to kind of complete. If we go 0.5, we're about 2 seconds. to clear that out, you just press the detune control and it takes you back to 0. Here's your glide time. Oscillator 1 is sort of your master oscillator by default. And so you can set up your glide time here, and all your oscillators will be following that. And that is because when we go to the frequency of these other oscillators, we can see oscillators 2, 3, and 4 have this 1 in parentheses. And what that means is they are going to be following the glide time that is set for oscillator 1. Now every oscillator does have its own independent glide time. So if we adjust these off of 1, now oscillator, let's dial our mixer. So we're just listening to oscillators 1 and 2. And again, if we want to clear out that glide time, we just press the knob. So there you can dial up different glide times per each oscillator, and so even if they're playing in perfect unison when you play an individual note, then as you glide, it causes them to detune and fatten during that until they reach their destination pitch where they will again play in unison. And if we increase this glide time, we can hear that beating change as they slowly shift their pitch there. Alright, let's go ahead and clear out this glide time. Go back to oscillator 1. The other thing you'll see here, I'm on oscillator 4 right now, and it says sync SYNC 1 versus oscillator 1 says sync with SYNCK. So the difference in the spelling there is this oscillator 1 is going to sync to the key, and that's why we have the K there. Now, if sync is off, that oscillator is free running. Now, as we get into a number from 0 to 360, that value is going to determine the actual degree of this waveform that it should restart at every time we press a note. So as we change this, we can see that waveform jumping as we change our sync. So I know, for instance, that this waveform, the peak of it is actually at 90 degrees. And if I want to jump in 90-degree values from 90 to 180 to 270 and back to 0, I can just simply press this encoder. And if you want to go back to 0 or off, just select 0 and rotate it that way. Now, in comparison, if we go to oscillator 2, 3, or 4, where we have this sync 1, that means oscillators 2, 3, and 4 are capable of syncing their frequency to oscillator 1, which we're going to consider our master oscillator. In order to hear that, let's go ahead and dial up oscillator 2. And I'm going to turn the sync on. Now, for there to really be any noticeable effect, I need to make the pitch of oscillator 2 higher than the pitch of oscillator 1. So let's do that. And obviously you're used to hearing that, let's say with some modulation going on. So let's say envelope 2, I'm going to sweep the pitch of oscillator 2, and I'm going to go to envelope 2 here, and I'm going to set a long time. Or I could go back to the frequency mod section. I'm going to turn off envelope 2 and now assign LFO 2 to control the sync. I'm going to turn up LFO 2's frequency. And we can select a different wave.